If you work with data, you've probably experienced the pain of having to deal with data trapped in really bad quality spreadsheets. I recently had the privilege of presenting alongside Duncan at a London R event hosted by UCL. Duncan is a brilliant data scientist who has developed some fantastic solutions for extracting this type of data. In his UCL talk titled "Get Good Data Out of Bad Spreadsheets," he walks through some of the available solutions, including his own package, TidyXL, and UnpivotR. I often get the questions from my students on how to deal with really messy data, and this right here could be your solution. TidyXL and UnpivotR are such great contributions to the data science community. I've provided links and details in the description below. If you know anyone who has to deal with these types of issues, please like and share this information with them. If you have any questions or thoughts about this video, please leave a comment below. In the meantime, please enjoy this talk with my new friend, Duncan. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos.
Hello, thank you for coming. What makes people angry? So Alberto Cairo is an expert in data visualization, so you might think maybe he was getting some data and he wanted to make a graph and something frustrated him. And what did he see? He saw something like this, and in fact he did see this is what he tweeted. And if you know anything about visualization libraries like ggplot2, if you did the workshop that happened earlier, was it? Great. You know that you can't make a graph of this straight away. You've got to do a lot of work. And the early disturbing slides I'm going to show you are just to build up a bit of intuition about what's wrong with these things. So I'm not going to go into loads of detail, but basically it's because it's got too many headers. So there's 2 layers of headers at the top, and there's kind of 2 layers of headers at the side. So here's one. If anybody came on the underground today, one of the things you might be interested in is what causes delays on the underground, what causes lost customer hours, and you'll find the London Underground Performance Data Almanac on their open data platform. And it's just a massive spreadsheet with dozens of tabs in it, and they all look like this. The problem here isn't just that it's got too many headers, it's that they're like mixed in with the data as well. So you've actually got 2 completely different tables which have been slammed together, and then you've got the year is like mixed up with the data, and then on the left, fleet is apparently equivalent to lost customer hours. Like those are clearly not the same thing. The reason people make those is because they're psychopaths and they think that's what you want. Okay? And that's why I made this one. So this was when I was working for the police and analysing speed camera data, and people were always asking us, how much money do you make from finding us for speeding at 4 kilometers an hour over the limit? And because I just hate people, I decided to put in 2 layers of column headers, and they'll never be able to draw a graph of that and publish it. Quite a nasty story about us. Unfortunately, if you zoom out on that spreadsheet, there's lots of data in there. So you're definitely not going to tidy that by hand in the spreadsheet. You're going to want to use a programming language. And more people like yourselves do know programming languages. So the thing I put in there to prevent you doing that is I made it so that the headers of the table at the top are misaligned from the headers. So there's some other examples. I can't remember where all of these came from. The one on the left came from Charlotte Gelfand on Twitter, and she's helpfully illustrated exactly what's wrong there. That's more than 2, that's probably like 3 or 4 tables, 3 reports slammed together. So these are tables that they share one common dimension. So all the tables on the left side share the year dimension, but they don't share any of the other dimensions. It's just like this n-dimensional spreadsheet projected onto 2 dimensions. And it's as horrible as that because that's horrible. On the right, it's a similar kind of problem. It's months rather than years. That's cash flows and expenditure. There aren't that many data scientists in the accounting departments that I've seen, probably because that's just awful. So here's a French one. This doesn't just have 2 layers of column headers, it's got 3 layers of column headers. And on the left, the row headers has got like totals in it, but the only way you would know they were totals, because you don't speak French and others are, well, I don't speak French, is because they're bold. So you'd need a tool to know that those cells were bold. Here's a couple more. Let's get New Zealand in it. So on the one at the back, that doesn't have either 2 layers of column headers or 3 layers of column headers. It's got both in different parts of the table. This one down here, the column headers, some of them are just red numbers, so they look like data. So any tool you're using to just guess your way out of this problem is going to think that's data. This one's from the Department of the Environment, Food and Rural Affairs. It's about farmland, how many farms there are and what their area is. This doesn't have column headers at all to describe the difference between the white columns and the grey columns. That's just described in text in the notice in the top left in green. Here we've got some Pokemon. I don't know anything about Pokemon, so maybe raise your hands if the colour on the left is meaningful colour, telling you something about Pokemon. Okay. Jenny Bryan sent me this one. I think she probably got it from Flowing Data, which did a visualization of this about a year ago, I think. So this is dog breeds and like their longevity, congenital ailments they have, cuteness, price, maintenance, how often they're abandoned. And the point I really like about this one is this cell down here. That's life expectancy, which I think is years. And they've cast some doubt on that. So how would you even encode? And that's a working dog, so that's been worked hard, that dog. And it's a sample of 4, so they all, yeah. So I'm here to try to convince you that in fact anything can be tidy. Right? A cat can be uncertainty can't be tidy, okay? So that cell can't be tidy because someone just has to think about that and turn it back into data. So Schrodinger's cat can't be tidy, but this cat can be tidy. And you get it tidy by thinking about what's the fundamental unit of cat, right? And it's fur, so like each of those millions of individual hairs is understood separately and manipulated separately in order to align it with the edge of the glass box. So if you describe a cat as just millions of pairs of fur, you can tidy it. And that's what animators do. So if they're going to animate a cat for a cartoon or a grizzly monster in Monsters Inc. or something, they build a database of that monster's fur and then they manipulate it as tiny data. And the photograph is also tidy. It's the same principle, because each individual pixel can be described in a tidy way. It has an X position, it has a Y position, and it has red, green, and blue values if it's going to be shown on the screen. So anything like that can be made tidy, and I'm here to reassure you that spreadsheets can be made tidy as well. And you would want to do that so you can get it into the Tidyverse, and then you get lots of powerful tools. So this is one way that I think about the Tidyverse, which is quite simplified. But it's helpful if you think that you put a rectangle of data in to a function, which gives you a rectangle of data out. And as long as functions all take rectangles in and give rectangles out, you can stack them one on top of the other. And that means each of those functions can be really simple, but stacked on one another, they can accomplish some kind of complex transformation. And then eventually you get to the output, which is probably not tidy, because you want a human to read it, not a computer. So the way this talk works is first I talk about how do you get the spreadsheet into a tidy form, into a rectangle, and then the second part is what simple tools can you use to gradually transform it from something really, really nasty into something really, really nice and get your graph out. So first, how does the data frame work? So data frames are nice, they've got some nice properties. At the top it says the dimensions are 8 by 4, which tells us straight away it's a rectangle, so every column has the same number of rows, every row has the same number of columns. And that's why we use them to describe something with one row per thing. So we've got one row per pupil per mark in a subject that they studied. You don't have to read across rows to understand the information you're being told. So you could look at just the first row and you've got all the information you need there to interpret that. You know it's 3 marks in potions in the first year and it went to wrong with it. The data types are also consistent, so you can use nice functions like max and mean. You could get the average of the marks. That's guaranteed to work because you know every cell in that column is a number. Compared with a spreadsheet, so this breaks all the rules. So it's not rectangular because there's a cell missing in the top left, and that will trip up a program that tries to read that in. The data types are mixed, we've got 10 really. There's meaningful formatting, so it's meaningful that Ron and Ginny's names are in bold and that the first and second year cells are indented. They're telling something, like you can understand, you could query that in your brain and get an answer about what did Ginny score in her first year potions, but you're not going to find a computer program that can figure that out. So this is what the standard tool, Tidyverse tool for reading spreadsheets does, is it does its best. It makes a guess about what the first column header would be. It's a blank cell, so it just fills it with ... 1. And that's the best possible guess, and it's nowhere near enough. It's converted the entire right-hand column into character because otherwise it wouldn't be able to handle the text value, which is 10 really, question mark. And there's no way you could query that to get the mark in herbology for Ginny in the first year, because if you filtered for that, you would get a text value of 9. And you wouldn't know it was Ginny. You would just know it was either first year for Ron or first year for Ginny. So here's where we get to the good bit. So here I've imported it with a tool that takes a different approach. It takes a cat hair approach, where instead of describing the whole spreadsheet in one go, it's trying to describe each individual cell of the spreadsheet. So if we look at the top row, that row of that data frame describes the highlighted cell in the spreadsheet. So we can see it's the cell in row 1, column 2, that's right. It has a character value, potions, that's right. It doesn't have a numeric value, and it's not indented. Let's check a couple of others. So this cell is in row 3, column 3. It doesn't have a character value because it has a numeric value, and it's not indented. And here we've got a cell that's in row 7, column 1, and it is indented, and it has a character value. And that's the entire trick. So we've now got a rectangular representation of a spreadsheet. And that's already powerful without any further tools. Often a spreadsheet has sort of metadata somewhere in it, in the top left or somewhere. It might give the data for data or somebody's name or the region of the country that that data relates to. And you can pluck that out straight away by just filtering for the cell in that position. You can also check for error values. So readExcel will import error values as NA, which is indistinguishable from normal NA value, whereas using this tool, you would be able to filter for a specific error value and check, hopefully, that it wasn't there. And these are the tools that will do that for you. So there's a relatively new suite of functions in Reader for doing this with plain text files. So that's for when a monster like has just exported the spreadsheet to CSV because that's what you asked for, and like, I know that doesn't make it machine readable, and you know that doesn't make it machine readable. So you need a tool like Melt CSV to wrangle that. Google Sheets 4 is Jenny Bryan's reboot of her Google Sheets package. It's not completely finished yet, but it's perfectly workable for almost all purposes. And she's provided the sheet cells function to import cells in that rectangular fashion you saw before, because she believes in this idea. And then finally, my package is the TidyXL package, which is what I've shown you just now, and that's the one I'll use for this talk. So we've got the data in the rectangle. Now, to put the spreadsheet back into some kind of tidy form, we need some simple functions that we can stack and gradually build those up to make that complex transformation from a 2D projection of an n-dimensional spreadsheet back into just an ordinary data frame. How am I doing for time?
Okay.
I just love this topic, so I'm just going to go on. Okay, so Unpivoter is my package of simple functions for doing this. And it handles all these things, so you've got too many headers, it can handle that. You've got meaningful formatting, well, because TidyXL tells you about formatting, you can use that information to resolve any ambiguities in the data. Non-text headers like dates, it will sort out. Other stuff that's just sort of hanging around the table, like people's notes, people's football pools. Several similar tables in the same sheet where they've broken it up into sections instead of breaking it up into tabs. Sentinel values, like, so R has NA to represent whatever you want, but they might use A and B and C and so on to represent special values in an otherwise numeric column. Meaningful comments, you can pull those out. So there's a few things. I'm just going to show you one function which is called behead. And what it's going to do is take this spreadsheet, and each time you apply it, it's going to behead one header from the outside of the spreadsheet. So we'll start with the top one, with the witch and wizard, and chop that off and turn it back into data, and then do the other 3 layers of headings. Just as an aside, that's what ReadXL sees when you import this spreadsheet. So ReadXL just sees something that it thinks has one row of column headers. So the first step, getting the rectangle, that's easy, that's a single step. Here we've got the rows, so the top row describes the first cell in row 1, column 1, and it says which. The second step is just to filter out some blank cells, so we still haven't used Unpivoter yet, and then select the columns we're interested in. A cell has loads of different properties. For example, it might have a formula behind it, it might have an error value, it's got a width and a height, and an unbelievable amount of formatting. So we've just got a little bit of that. And then we do this. I'm really sorry about the NNW. That's not intuitive. I've realized that now, and I'm going to fix it in maybe in the next few weeks. What that means is, so that's a direction, and it's trying to describe the direction you take from a data cell to the header that labels that cell. So if we look at the highlighted cell, so we've got the cell here, 7, which is a mark for Ginny, and Ginny is a witch. So the north-northwest direction, NNW, says the way the 7 cell relates to the witch cell is you go north or up first, and then you go west or left. I'm going to change that to be up left, because it's just embarrassing talking about that kind of thing. I wasn't sure if witch and wizard is really gender, or just like where they, yeah. So we've now stripped that layer of headers off. They've become labels. We now do that second time, and this time the direction is just straight up or north. And that's added a column to the right for the pupil now. So they've got their names. So the 7 is associated with Ginny, and the 2 is associated with Hermione. If we go back and look at this, this is like 2 columns of row headers, but they're all in the same column, and they're only distinguished by formatting. So we're going to have to do something slightly tricky, which is look up whether each of those cells is bold or not. And then if it is bold, we'll treat that as a header in the first instance, and then we'll come back for the others. To get the formats, Excel formats are kind of like a list of lists, so that's how TidyXL deals with them. Google Sheets deals with them in JSON, which is also a list of lists. It will feel a little bit different, but it's essentially the same idea. So all I'm doing here is I'm reading the formats, which is a list of lists, and then I'm going into that list of lists to find a vector at the bottom that just says true, false, or 0, 1 for whether a cell is bold or whether it's indented. And in that vector, you look up the position in that vector using the format ID of the cell. I've explained that very quickly. It's much better explained in the documentation than in the links at the end. I'm just trying to give you an intuition about this. So you do that and you say the head if. So you're saying if one of these cells on the left-hand edge, if it is bold, then treat it as a header and chop it off. And that's what's happened. So we've now got a location column on the right-hand side. So those bold cells on the left have become labels of the data. And we can check that by looking at the charms and potions cell. It seems a bit weird to still regard the charms and potions as data because we know they're not data, they're headers. But we're just going to strip those off at the end. So this is the tidy style where each function improves the situation a little bit until you've finally finished. So far we haven't completely improved the table. We've still got some headers that look like data, but when we do the final step, it will finally be clean. So here's the final step and then a bit of cleanup. We've taken the subject off, the subject's now become a label, and we can check the cells. And now this table is recognizable as tidy data. And you can test that because you can say, if I look at one row, have I now got all the information I need to describe the information? Yes, I have. Ginny got a mark of 11. She's a witch. And the subject, oh, I haven't got the subject. What did I do? Mistake. Apologies, that will be fixed. I think the code's correct, but I didn't change the image. It's not a mistake, okay. Look, second row, right. Ginny's witch got 6 marks in charms in the castle, right. The other row is the bold row, which has got an 11 in it, which is like a total for all the subjects that she studied in the castle. And it's up to you to decide whether to leave that in the table or not, because you can easily get rid of it by just filtering out all rows that don't have a value in the subject. So now you can do your plot, and I'm sure Alberto Cairo would be really proud of this one. It's looking at the distribution of marks, witches versus wizards. And like the witches look like they're doing slightly better on average, but there might still be wizards who are better than some witches and vice versa. So here's what we've learned: 1 row per cell. Those are the tools that can get you there. Then you apply a series of the head steps to tidy them up, and that's the package to get you there. There are other functions in these packages, so do take a look at those if you've got a spreadsheet that you're having trouble with. One that's quite useful is if you've got a spreadsheet like this, where so David Robinson, who was at Stack Overflow and now Data Camp, He made this famous, and Jenny Bryant found the spreadsheet, I think, it was like in the Enron corpus. So if you've got several tables that are all the same but they're spread out over the sheet, like small multiples, then partition is the one for you. These are all the functions in the TidyXL package. There's ones in here for dealing with the formulas that are behind cells, so sometimes it can be important if people like put a constant in the formula of a cell and you need to get that constant out of the cell, you can do that. So I searched thousands of spreadsheets for the worst possible formula. So you can parse the formula and it tells you how it's all nested and stuff, so this was the most nested if statement that I could find. And it also has loads of constant values in it. And it's kind of upsetting to think that that was from a financial planning spreadsheet that was talking about tax in the 48 different states that Enron operated in. So that's their tax return right there in one cell. To find out more, I've written quite a bit of documentation, most of which is still up to date. This is an online book-down book. I've also got 4 videos on YouTube, which is they're long, dull, just like put them on, fast forward, and then browse your phone while you're listening to them. Go to that link if you want to actually have a bit of a practice in an environment that's been set up for you. So there's like an exercise that's being worked through, and you can teach yourself how this all works in that RStudio Cloud project. That's me.
Yep. Questions? Adam?
Can you package the work data as a column?
Yes.
Very tidy.
Back to the second to last.
So thank you very much. I think I will be downloading the package tonight and making heavy use of it. It's a depressing amount of my life is spent doing this sort of thing. My question is that often my instinct is to try and write a cheeky little script to automate at least some of the wrangling rather than do things manually. And then a lot of the time I'm like, actually I could have just sat there and copy-pasted this by hand and have been better off. Where do you think you draw the line? Like how big of a nasty spreadsheet does it need to be worth trying to automate it, at least partially?
Lots of copies of a small spreadsheet. A small spreadsheet that you will see again. A spreadsheet that's like collected regularly and you're not sure if it will be exactly the same next time someone sends it to you. Or a spreadsheet with more data than you can see on the screen at one time is my sort of rough guess. But I have heard from people that they learnt it for one spreadsheet and they reckon it was worth it just for that.
Okay, last one, there's already one there.
Yeah, obviously, thank you very much. It's great to see you trying to do a presentation on this. I know how hard you've been working on it the past couple of years. Yeah, I feel like this is like the less glamorous side of what we all do. I feel like our vocation in the 21st century is cleaning up all of these horrible, terrible spreadsheets that have got such valuable data. And like this is one of the tools that I've got in my toolbox nowadays to do it. My question really is like, Duncan, what's been your, what have you discovered in the past few years of the impact of this as an open source project? I mean, I feel like you could have made so much money on this, and
I don't think I could have made any money on it. So the Office for National Statistics paid a company called Sensible Code.io to do something similar in Python. So there was already something open source, and they developed that at the same time as I was developing this. So nobody would make money out of this. Like it doesn't do anybody any good. It's much better for my career to develop an understanding of R and then start talking to people about it. And that's how open source works. Like we get paid to do boring jobs, and then do more interesting stuff and promote it in order to win like a reputation or something.